Now, the types of testing, also oftentimes we focus on the good test. So we test the cases or the situations that are the correct situation or the proper situation. Okay, so if you're testing like a password validation, you would enter a correct password and see whether you will be able to enter, right? If you are testing like access to a URL, API, you would test, like you create a situation that is proper. So you try to put the correct URL, try to put the correct input. So you are testing the good situation, the proper use of this function or the open system. Okay? But oftentimes the bad situation, the bad situations are less common or not as focused on as the good situations, but they are still important. So how would your system deal with situations that are not ideal? How would your system deal with a bad input or incorrect input? All right. So that's also needs to be tested. So if you are a login system, you test when you put the correct credentials. So that's the good. When you put the bad credentials, that's the bad test. It needs to also be tested. Now the one that is most often neglected is the boundaries. So the situations that are on the bounds, on the boundary. Like if you are working with an array, an index out of bound is a very common problem. Why? Because the boundary situation of trying to accessing the last element of the array or the first element of the array are often not tested. So the bug would not be revealed until you actually are using the system and then the system crashes on you. Okay, 1 second. Okay, so when we talk about numeric values, testing things at the boundaries are very important because that's where the problems often happen, and that's when the testing is often neglected. Okay. Okay, so let's have an example. So we have example class under test. So this is the class that we want to test with password validator. Okay, now these are the requirements of that class. So in order to validate a password, the password must be at least 8 characters, and then there are at least one special character, and then at least one uppercase character. Okay, these are the requirements. Now let's talk about the first function. So every requirement is implemented as a function in that class. And then now we want to test that function. Okay, so we have a function that checks the length of the password. Okay, and we know that this is the requirement, so we need to create the test based on the requirement, not based on the code. That's another issue here, that when the developer creates the test, if the developer had a bias or misconception or misunderstanding that they implemented in their code, they will create the test with that bias as well, or with that misunderstanding as well. So let's say we're creating a system that transfers the temperature from Celsius to Fahrenheit. If the developer thinks the equation, like there's a mistake in the understanding of the developer about the equation, so the developer will will implement that mistake, right? And then if the developer will create the test, they will create the test based on that mistake as well, or misunderstanding as well. So that's why it's also recommended someone else test your code. So when I ask you to test, it is, if you can, if it's possible, try to switch. So if you created the code, you create a test of someone else. Okay. So we should create the test based on the requirements, not based on the code, because the code, the mistakes in the code is what we are trying to reveal. Now here's the one test case. So this case would look like this. It consists of input, expected output, and then when we execute the code with this input, there will be actual output, and then the comparison between the two would give us the result. Okay? So here's an example input, empty password. Now, when we send the empty password to the checklist function, it should return false, right? So that's what we expect. The expected output is false. Now, the actual output is the result after execution. Now, if the result after execution is false, then the result of the test case is either pass or fail. So if they match, all right, if they match, then it's pass or success. Okay, it's not always match. We can create the criteria in which the result is pass or fail. It could be like if you have a function that generates a number, this number has to be more than 20, or generates a number other than 0. Okay, so the equality is not the only way to determine whether the test case passed or failed. Okay, but it is common way. Now, when the expected is equal to the actual, then that we say that the result is, this case passed. All right. Now, how can we create? So this is the was like that example. Was it a good or a bad or boundary? I think. How can, yes. So is that the proper way to use the function? Yeah, so that's the bad. So a good test would be something above 8, because that's what we wanted to happen. Okay. So a good test is something above 8, and then the expected output is true. Now, when we send the code to the function, and we collect the output, it depends whether that determines whether it's pass or fail. Now here's another bad. So we took the empty. So the empty can count as boundary too. Okay, but it's like kind of bad boundary. Another bad is something below 8, way below 8. Okay. Now at the boundary, they could be good or bad. Now the boundary of the 8 number, and I suggest that the boundary you need 3 tests. Something on the boundary itself, something below, something above the boundary. Okay, so the boundary is 8 characters, so we need to test on the boundary 8 characters. Okay, so it would count as good, but it's also boundary. Now we can test for something below, right below, so 7, and right above, so 9. Okay, so only 7 would be bad. Okay, unless we're not accepting the 8, we're expecting something above 8, not equal to 8, then the own boundary test will reveal that. Okay. Now, when we combine all these test cases, so we're trying to test different aspects, different paths, different ways for the code to be executed. We put them all together. This is what we call the test suite. So when I ask you to create a test suite for your class, so this is the collection of all the test cases or that are testing the functionalities within the class. Okay. Now, when we get to the execution, and we need, in order to actually perform the testing, so that's kind of a planning for the testing. Planning for the testing means we prepare the test cases. What is the input? What is the expected output? Okay. Now we need to execute these test cases to figure out the actual output, and then based on that, figure out whether the test would pass or fail. Okay. So in order to execute it, we can execute it manually. So we can just run the code and enter the functions manually, the values manually, and then collect the results manually and keep the comparison all manually. Okay, we can do that. But this is not the most efficient way to do it. Automation is something would make the testing much more efficient. And there are a lot of frameworks that are created for automating tests. Okay, so instead of just running the test case manually and keep tracking of everything with a pen and paper, you can use one of the testing frameworks to automate the entire process. In Python, there is a framework called PyTest. We'll talk about it in a bit. But in order to execute, so we need to execute the code itself with the given input, and then we need to capture the actual output. We need to compare the expected to the actual, and then decide whether the test pass or fail. Okay, that's the execution of the test. Now we can use something like PyTest, which is a framework that is used to automating test cases. Here we're talking about unit test cases, white box test cases. Okay, you can install it. It doesn't. It's just like we installed any of the libraries you've been installing. It's the same way. You can install it with pip. But it's not just a library. It also comes with a command line tool. Okay, so this command line tool needs to be added to the path, the environment variable that's called path, in order to be executed. So if you try to test it, so you say PyTest minus version, it should give you the version if it was installed properly. If it didn't, then it's not seen. Like if you see that there is a success, now we see there is a successfully installed. Okay, but when you try to print the version or try to pull the command, nothing comes up. It means it is installed, but it's not seen. So there is a hint here that tells you need to add this into the path environment. Okay, so that's so that we can use the command line tool that's called